So hey guys, and welcome to this tutorial on iterators and generators, a very important topic of intermediate Python. And today we shall touch upon its basics and look at some advanced concepts. Starting off with iterators, they allow efficient looping and memory management in Python. Iterators provide sequential access to the elements of a collection. They do not expose the underlying structure. It remembers the current position in the sequence. You cannot rewind the iterator. It uses the built-in function iterator to define an iterator and next to move on the iterator forward. Now let's start with iterators, and now we shall see how their working differ from a normal for loop for iterating items in a list. So let us first create a list and then we will iterate through the items in the list, normally using a for loop. So here you can see that the items in the list are returned 1, 2, 3, 4 and 5. Now we shall look at the type of list 1, and it will return us that it is a list type, which is obvious. So now if we print list 1 directly, we shall see that it has returned us the values in the list along with the structure. So the structure is not hidden when we print the list directly, and if we are not using iterators. Now we shall use iterators and see how they handle it. So as you can see, upon printing the iterator variable, it is not giving us the structure or the value stored in the list. It is simply returning us a list iterator object which is stored at this memory location. So here you can see that iterators do a good job at hiding the structure and the values which are present in the list or the collection it is iterating upon. So, but when did we use iterator, or how did we create an iterator on this list? It was using this iter keyword. When we use this iter keyword, the variable we have used or assigned to it becomes an iterator. So now if we want to look at the type, it returns us list iterator. So what if we want to iterate through the elements like we do in normal for loop? What if we want to get the item stored in the list, the value stored? So the keyword we used here is next. Next is a built-in function which help us to get the values which are stored in the list and what the iterator iterates. So the first value has been returned to us by using next. Currently next is pointing to the first value in the list, and if we simply copy and paste it here, it will move on to the next value in the list, and we keep on doing this till we reach the last value, which is 5. Now as you can see that we have reached the last value 5. Now we shall see what happens if we again write next. Stop iteration is raised. It tells you, stop right there, good sir, you have reached the bounds. But how shall we handle this now? Simply using a try except block. exception should be this stop iteration. Then we shall print no elements left to iterate. As we had reached the last element, so it is returning us that no elements are left to iterate. Iterator seems to be a bit lazy, right? Printing one element from the list at a time. That's because it works on lazy loading. That is, picking one item from the collection at a time until it's given a command to move on to the next item. So, understanding this internal flow helps you write cleaner, memory efficient loops, especially for large datasets. Now, let's look at custom iterators. We shall now see what is happening under the hood by building our own iterator. Now write the next function. Oh, sorry. If self.current is less than equal to 0, it will raise the exception stop iteration. Else, we will decrement the value by 1 and then return it. So this is our class of a normal custom iterator. Now we shall call it using a for loop. We want to see a countdown from a number 5. So here we got the countdown from number 5 to 0. When you create an object like countdown 5, it stores a starting number 5 inside self.current and then it starts the countdown by decrementing the value by 1 till it reaches 0, and then it stops because here we have written that on reaching the value 0 or less than 0, it will raise a stop iteration. But wait a minute, a subtle detail. Notice how the first number printed is 4, not 5. That's because the code decrements first before returning it. The solution is to create a variable val, or any variable name you can give it, which is equal to the current value self.current before decrement statement and then return that variable. So what we were doing earlier, we were implicitly creating such a class, but Python handled it for us. And now let's move on to generators. They are a subclass of iterators, a simpler way of creating iterators. They use the yield keyword to convert a function to a generator. Just like iterators, they are also lazy. That is, they perform lazy loading too. No need to manually track indexes like lists or loops. They remember their current execution state between next calls. Now we shall see generators by defining a simple function of cubing numbers. We'll use here the yield keyword and then cube. So this is where generators kick in. When we use the yield keyword, this is where we showed our intention of implementing a generator. The function cube n became a generator when we used the yield keyword in it. Now we shall call cube of any number, suppose 5. See, as it is a subclass of iterators, it is not giving us the underlying structure or the value stored. It only gave us a generator object cube which is stored at memory location this. It did not give us the values of cubes till the number 5. But how shall we get it then? Using the obvious built-in function next. Next of var. So this is the first cube of first value, which is 0, because we were using a range from 0 to 5 minus 1 4. And then after printing next of var again, we got cube of 1, which is 1, cube of 2 8, 27, 64, and we won't get 125. Stop iteration is raised. But there is also a way of shorthand expression, just like list comprehensions, but this one is lazy, and this is how we shall define it. So this is a generator and not a list. Now we talk about the send method. Most people think that generators only yield data, but you can also send data back in, making them two-way communication channels. Let's define a function named greeter to check this out. Yield hello the name. Here we will pass on the variable value. Now let us create a generator. Print the next value in the generator using next of g, and this shall give us a value or the output. What's your name? And as for printing the value of hello with the name, now we shall use the send method. Send a string And this statement should give us a string value to the generator and print the greeting line with the name of the user. Let's see. What's your name? This is the output of this line. And hello Abhishek, which is the output of after giving Abhishek, which is a string value, to the generator. And it will yield hello with the name of the user. This is how coroutines were originally implemented in Python, a beautiful concept that inspired async and await later on. These were the basics of generators, and now we shall look at what we discussed earlier about iterators being efficient for looping on large dataset files with a practical implementation on a large file. We'll define a function large file reader. Read only mode, as you only have to read the file. Line in file, sorry, yield line. This is our function of reading large files, and now we shall call it for example. We will use an article on agentic AI which has approx 400 to 500 lines, and it's a text file. For line in large file reader, given the file path, print line dot strip oh sorry, there's a spelling mistake. Okay, so there was some error with the file name which I have rectified, and now we can see that it has returned us the whole file line by line, and it has not suffocated the memory of the system. Now we shall end today's tutorial with final topic on how to close a generator. We'll define a simple generator yielding 1 infinitely till the exception generator exit is raised. Then it shall print generator is closed. Now we will call this function oops, one missing quote. Now print next value from generator, and then g dot close. This will close the generator. This method here actually triggers generator exit, which is this exception. So as we can see, that infinite one yielding function or generator named number is closed when we use this statement g.close. This allows cleanup, useful for releasing files or network resources, a good practice for efficient memory management. And now we have reached the end of today's tutorial in which we saw the basic functioning of iterators and generators. And we also touched upon some advanced topics like reading large files using generators. And we also saw the working of iterators by creating our own custom countdown iterator. I hope you have understood today's tutorial and the topics covered in it. Don't forget to download the practice assignment from the link to the Google Drive in the description and refer to the solutions once you have attempted on your own. Take it easy, guys. Keep working, keep practicing. So long.